Are we live? Oh, okay. Yeah, we are. Sorry, there's like a 15-second delay, so that's what I was doing there. I guess I'll just wait a bit and let people join. Probably also makes sense if I shared my screen as well. Maybe it's a good start. Okay. Okay, I guess I'll just get started. It's 1 minute past 4, so yeah, I hope you guys could see my screen. Yeah, you can. Okay, cool. So, hi, I'm Fraser. I'm the president of the Financial Technology or FinTech Society. I'm here because the Future Conference have let me come in for an hour. And sorry, I could hear myself. Sorry, the Future Conference have let me come in to give a workshop on blockchain, an introduction to blockchain, what it is, what it's used for. And also I'll talk a little bit about one of its most famous applications, which is cryptocurrencies, which you've probably heard lots about. I know also tomorrow that there's like a crypto trading workshop, so hopefully that'll set you up for this. This will set you up a little bit for that, so you know what's going on with there when you come in. So I guess the first question you'd ask when you're thinking about this is, why would you even care? Like, why should you learn about this? If you're not someone who studies computer science or is involved in finance at all, why is it important to know about it? And I think there's a few reasons. I kind of highlighted these here in these news articles I've got. So there's this one guy who had like $120 million worth of Bitcoin in his computer, and he lost the computer, and the council refused to let him search I think it was in like a garbage facility, and they wouldn't let him search it. So I think if the people in that situation knew a little bit more about the fact that he literally couldn't get this cryptocurrency back and it was worth so much, or we had some sort of laws to help get that back, that could have helped. There was another case of this woman called the Crypto Queen, who created an entirely fictional cryptocurrency, scammed people for billions of dollars, and then disappeared without a trace. And again, I think so many of these people were so excited that like they'd heard about Bitcoin, they wanted to get rich. And if they'd known a little bit more about it, they probably would have sensed a bit faster that it was just hot air. It's like the general public hears so much about cryptocurrencies, but nobody knows what it is. And that's all kind of validated by this survey that I found that says that 59% of people have never heard of blockchain. And of those people, 80% don't know how it works. So I think there's definitely a lack of understanding that I think is easy enough to fix. And that's my hope. So that's my hope today, is that blockchain are more common sense than you might think, and we're able to build up to it from simpler ideas. So we'll kind of start off with bartering, which is what people did for thousands of years, move on to paper money, which is what we understand, and then hopefully get to cryptocurrencies, which some people would say is the future of money. Before we do that, I'm just going to double check that this stream is all working and things. It's my first time using this. And yeah, I've not got any comments, so take that as a good sign. So forget everything you know about money. Forget about paper money and cryptocurrencies and stuff. Let's just focus on bartering. So you kind of probably have an idea of what this is. It's just the exchange of goods and services between people without any shared medium of exchange. So like the example here on this photo is a guy trading a chicken for a newspaper, which we all kind of would think is ridiculous now, but it seemed to work for years. People did it for a while. And it's kind of low maintenance. I mean, right, you don't need to have any sort of trust like with the person. You just give them whatever it is that you happen to make. Maybe you're a farmer, so you give people chickens. But there's also some clear problems with this. And I've not done this before, so I'm going to try. But if any of you guys could think of any problems with this off the top of your head, and put them in the chat, and I will see what you guys think. I'm coming out loud and clear. Thank you. Yeah, so does anybody have any idea why bartering is kind of a bad idea? Why we've left it behind? I think there's a 15-second delay, so I will wait and see. Yeah, exactly. So Rachel says that, like, who decides how much stuff is worth? Like, is 10 chickens worth 10 goats? Like, everywhere you go, you're going to have a different standard for what things are worth. So you're kind of constantly playing this game with other people, of negotiating. And yeah, and carrying goats is also a pain in the neck. So you really do have this issue. It's actually quite hard to do some trades because if you want to buy really expensive stuff, you've got to carry goats or chickens around everywhere you go. Which is extremely cumbersome. And yeah, value changes with time. So like if you're a farmer, you can't really save up value in any way because you can't really save the chickens. You kind of have to sell them. You have to use them in some way as soon as possible. You can't save up chickens. Things deteriorate, I guess would be the word for it. And this kind of all has the effect of like, you really can't have, you really can't have very complicated professions. So like if I'm a computer scientist, I can't really just like build people websites every time I want to buy a newspaper, right? I need to have something of value. So it's difficult to have these kind of abstract professions that the only professions you could have are ones with real intrinsic wealth that they could give to other people. So we have some problems with bartering, pretty clear problems. But how do we kind of formalize these ideas and think about, how can we compare it to other systems of money? If we come up with a better idea, how can we know that it's actually any better? And so this was done in the 1800s by a guy called William Stanley Jevons. And he looked at money and bartering and he said, well, there's kind of three properties that are really important. Three functions of money. So it needs to be a good medium of exchange. So everybody agrees it has worth. Like, so you can go into any shop and give them whatever this item is. It might not be paper money, it could be anything. And they'll trade you for the same amount as they would, which is what we mentioned before of if you were to use chickens, everybody would have to agree that they're worth something, or else you have to play this game all the time with other people. It needs to be a good unit of account, which means that it's fungible. And fungible kind of just means that like one is like the other. So like whatever item is you're using as money, you kind of want one of those things to be equal to another one of those things. It seems like an obvious thing. And it also needs to be divisible. So whatever it is, you can divide it up into small enough amounts to buy really cheap stuff. And also you can keep it small so that if you have to buy really big stuff, you don't have to cart loads of it around. And it also needs to be a good store of value. So it keeps its value over time. It doesn't deteriorate. And it doesn't have any hidden properties that might come about and change its value overnight. So of course, going back to bartering, how does it perform in these criteria? Well, pretty badly. As a medium of exchange, well, it's kind of bartering is kind of defined by there being no medium of exchange. So it's terrible. As a unit of accounting, it's really bad because not all items are easy divided up. And as a store of value, it's really bad because things deteriorate or they might have hidden qualities. So it's, yeah, really bad. That's why we left bartering behind. And then people have come up with different solutions over human history to kind of counteract the problems of bartering. And so the second attempt that we would have is a trusted object. The most kind of common one people would think about, I think, is gold. So gold's quite rare. It looks quite cool. So most humans would agree that gold is has some sort of intrinsic value. And so other cultures throughout the years have used seeds, arrowheads, cocoa beans, all sorts of funky things that they could get in nature that had intrinsic value. And so it's a bit better. As a medium of exchange, it's okay. It's not very good for expensive transactions again, because you kind of have to cart it all around. It's not always divisible well. How do you divide up something like a seed or cocoa beans? And it's also forgeable. Like if you think about something like gold, there's a really well-known stone called fool's gold, which is absolutely worthless, but it kind of looks like gold. So it's quite easy to trick people into thinking you've got money when you don't. And as a store of value, I mean, you think about something like gold, it's a pretty good store of value, but again, seeds, cocoa beans, they go out of date quite quickly. And if you think about it as well with gold, if somebody came along and found a method of turning gold into something that's much more valuable, so maybe they melt the gold down into another metal, then that changes the value of gold overnight. So its store of value is kind of in question. So what we need is something man-made, something that we've kind of created ourselves that we can kind of control a bit better. And this is where paper money comes in, which we're all kind of familiar with, like we all use it every day. Another word for it's fiat money, and it essentially relies on a trusted entity to kind of back the currency. So the way it would work normally would be that some sort of central bank would print these notes, and then the government would kind of enforce the notes and tell all the shops, this is legal tender, you have to accept it. So it's all kind of relies on this central power to enforce it. But it works pretty well. It fixes a lot of the issues. So you can see as a medium of exchange, it's really good because the government have said, you have to accept this if you're a shop. But it kind of falls apart if you go to a different country. Like you can't spend pounds in France. So as a medium of exchange, paper money really only works if you're in the right place. As a unit of account, it's good. We've made it ourselves, so we could divide it up into pennies. We could create like £100 notes. So accounting is quite easy to do. Of course, now you have digital money as well, so that's even easier because you're just sending signals. But as a store of value, you really are beholden to this trusted entity. And like there's been plenty of instances in the past where like poor monetary policy or poor regulation with the banks has kind of caused this whole thing to fall apart. So there was like the situation for instance, in Germany after World War II, where the government printed way, way too much money and it caused hyperinflation. And the money became so worthless and lost so much of its value that the German people actually had to resort to bartering, which is kind of funny because we just talked about how this was supposed to fix the problems, bartering. So ideally, you would want to remove this trusted entity. You kind of want a system where there's no trust. It's just, there's no one party that could kind of take the whole thing down in one fell swoop. Before we go, I'm just going to double check the chat. So I was saying that, another example of when there was really bad hyperinflation was in Venezuela, which, I think that was one where they were like carting their money around in wheelbarrows because it was so worthless. So yeah, look at Venezuela and Germany if you're interested in that. Okay, so this is where our fourth attempt comes in, which is kind of why you're here. It's cryptocurrencies. So as I said, cryptocurrencies is obviously, it relies on a lot of computer science and a lot of mathematics. So I hope I can kind of keep it as simple as possible and kind of build up to it from some simple ideas. So if you imagine we'd start out with a group of friends. So these group of friends, they go out for dinner every night. They'll sometimes pay for each other's meals. Like I might pay for someone else's meal or someone will get the whole bill. But the point is that they'll build up debt over time. Like sometimes I'll owe a lot of money, but then I'll pay for someone else's meal, so the next night I won't owe as much money. But this will happen over a long period of time. And this group of friends is also lazy, so they don't want to transfer money every night. They want to just kind of track it and then maybe settle up in a few weeks, every so often. So they start writing down on a ledger. So they get a bit of paper and pen and they write down, Fraser pays Sid £10. Abdullah pays Fraser £15, just tracking everything that happens. And it would be quite simple if they ever do choose to settle up. Whoever owes money puts all their money into the pot. So you have this pot full of money. And then whoever's owed money just takes out whatever it is they're due from the pot. So in this example, I don't know if any of you have done the maths, but if you went through and you'd figure out that myself and Sid would get some money, while Christine and Abdullah would lose some money. If anybody's interested, these people are actually the FinTech committee, the FinTech Society committee. It's the only names I could legally use. But the key thing about this is that they could add to this ledger forever. Like they don't actually ever have to transfer money if they don't want to. Like as long as they kind of all agree, like if no one person builds up too much debt, then they could do it forever. But again, there's one big problem with this. Responses before. Could anybody think of any problem with maybe writing down transactions on a piece of paper, on a literal piece of paper with pen? How could people abuse this? I don't know if people are shy or the lag is just more extreme than I realize. Someone cheating, yes, exactly. That's it. It's a piece of paper, so like anybody could write on it. They could erase transactions, or I could add a transaction saying that someone owes me a lot of money. It has an element of trust again, which is what we're trying to avoid. So somebody has the bright idea of like, well, if somebody wants to give someone else money, maybe they should do something to prove that they kind of agree with that. So you start signing it. So every time I say I want to give someone else money, I have to sign it off to confirm that it was me that agreed to do that. Then of course you start thinking, well, it really is just pen and paper, so I could just copy someone else's signature. And then you think, well, maybe we do fingerprints or something, but it's not really going to cut it. So we have this problem of being able to verify people's transactions. And then one of them also realizes that this ledger is becoming quite big, and it's becoming quite difficult to maintain. So the computer scientist in the group says, let's take this all online. Let's do it digitally. How about we track this all in a spreadsheet? Ignoring the problem of signatures for now. So you can imagine something like a computer program that tracks all this. It's the same information, it's just online in a different format. And you would have different computers, and everyone who wants to take part in this would have their computer, and they would communicate over the internet, and they would send each other transactions. So whenever Bob wants people to know that he's going to send me money, he'll tell everyone on the network over the internet. You can kind of imagine they're emailing these to each other or something like that. But again, like, how do we even sign a transaction digitally? Like, what does that even mean? This is the big problem we need to solve to remove this trust from the system. And so this is where we introduce cryptography, which is the kind of the hard maths of this. So I'll try and keep it as accessible as possible. But so the idea behind this is public key cryptography, which is a big thing in computer science, really important. But so in this system, you can imagine for now that everybody has two keys, and they're like literal keys to open doors. Everybody has their own public key and private key. So you keep your private key secret, like you never ever tell someone your private key. And you send everyone a copy of your public key. And what you can imagine is that if Alice wants to add a new transaction to the ledger, she puts it into a box and locks it with her private key, and then submits it to everyone else, sends it to everyone else, saying, here's my new transaction. And what people could do is if they get this box from Alice, they could use her public key to open the box and look inside and see the transaction. But they could only look inside if they could only unlock it with Alice's public key if it was actually locked with Alice's private key. So this is just essentially a way of Alice kind of protecting the transaction with something that only she could lock it in the box, so only she could have actually made the transaction in the first place. If somebody had her private key, they could start making transactions for her. So I guess more kind of concretely, this is all done with maths. So this is all done on computers with mathematics. And in reality, the keys are really long numbers. I think it's something like dozens of digits long. I think these are real keys that I put in there. So what you do to get a digital signature is, so you take the transaction. So the transaction might be Fraser pays Sid £10. You turn that into numbers. Like you could do a simple substitution. So you could turn A to 1, B to 2, F goes to 6. You turn it onto the numbers. You kind of combine it with the private key, which is also a number, using maths, combine the two of them. And you'll get this other final number out of the end of this, just a jumbled mess of numbers and digits. But the key thing is that what the maths allows you to do is when you get this jumbled mess of numbers at the end of this, you can undo that jumbled mess with the public key. But you can't get the private key out of that process. So you take the transaction, you mix it in with the private key, you get this mess out, and then you can send that mess to other people, and they can use your public key to undo the mess and get the transaction back. But it's when you send people this mess, they know that you've created that mess because your public key can undo the mess and give you something reasonable back. So I hope that's fairly clear. I really haven't got into too much detail with the maths because it's kind of, there's some hard stuff to do with prime numbers, etc. But the key idea behind this is that it's just a way of you signing off a transaction in a way that no one else can forward a transaction for you. It's a lot more, because it relies on math, it's a lot more powerful than something like an actual handwritten signature. You'd kind of have to break the laws of maths to be able to solve this. And I guess a key important note is that the final output of this process is a binary number because, you know, it's computers, kind of everything is binary. It's all this kind of being done in binary. Okay, so let me just double check the chat. How do you keep count if there's a common pot? Okay, sorry, I'm just checking the chat now, so I'm just gonna answer some of these questions. How can we keep count if there's a common pot? So I think that question was about the ledger at the start. I'm guessing. So in this case, when we're talking about the ledger, and we're talking about putting money into a pot, I guess there's kind of some trust involved in this idea, but I guess the idea would be that if everybody just puts in what they owe, then you have all the money there, and there's like a set amount of money there. And as long as everybody takes out only what they're due, you should end up with an empty pot, and everybody has all their money. But this is a bad system, so we will leave that in the dust. Okay. Sorry, just double checking. So, okay, so we now have a way for people to sign transactions digitally, and we have a way for us to send transactions over the internet. No more fake transactions. Good. And the nice thing about this too is that kind of anybody can join this network now because it's over the internet. All you really need is a computer, and you'll join up. You'll download some software. It will generate a public key for you and a private key, which you'll never tell anyone. The private key, and you can send that to everyone. Send that over the internet. Send it to computers on the network. Send it to your friends, and then they now know who you are. They have a public key associated with you, and they can send you some money. And now you have your first bit of money, and that's you part of the network now. And then you can go send that to whoever you'd like. And then I guess, as I kind of hinted at now, is that now that you have so many computers in this network, the way that we keep everyone up to date with what transactions are going about is we kind of have this gossip protocol. So every computer kind of knows some other computers. It knows like their IP addresses. And you'll just tell your neighbors, you'll just tell your friends, oh, I heard that Sin is going to pay Abdullah 3 Bitcoin. You tell them, and then they tell their neighbors, and it spreads around, and hopefully gets around everyone eventually. But the idea is that the network is so big that you really have to spread it in a way like this. Like you can't just have everybody listening out. Like everybody can't just be simultaneously listening to millions of other computers. So I guess the interesting thing, if we take a step back and think about what we've actually done, is we've kind of created this whole new currency. Because, and you could call it Bitcoin, you could give it a symbol with a B, but because it's completely digital and everything's people are kind of sending each other transactions all online, it really doesn't relate to pounds anymore as strongly as it did before. So like I could meet up with you in person and I could say, I'll give you £2 for 1 Bitcoin. And then that's kind of the exchange rate. So it's its own thing. And if you want to transact Bitcoin for pounds, that kind of happens outside of this whole system. So from now on, we could call this Bitcoin. And I guess it's kind of obvious now that I'm hiding this. This is a cryptocurrency. This is really how it would start out. And this is how something like Bitcoin would start out. So I'm just checking the chat again. So Rachel's asking, message plus hex equals binary. Yeah, so in my earlier slide, I was considering making this a bit longer, but this is very not concrete. In reality, it's more like you turn the transaction, which is made of letters, into binary. You also turn the key, which is a number, into binary, and then it all comes out as binary. But I could leave some links actually to better explanations of this. But yeah, I guess for now, just think about it in terms of there's some really complicated maths that combines the keys and the transactions together to give you this final signature. But yeah, that's not very super detailed in my slides. Sorry. Okay, so to recap, what have we done? So we've made a currency, its own currency. It's completely digital. You don't need, you only need a computer and the internet to join. It's not government backed. And you can make payments just by broadcasting a new transaction over the internet. And it's kind of solved this problem that there is no trusted authority. It's really bright. There's no trusted authority. There's no kind of government that's authorizing your payments for you. It's kind of overseeing it. And hopefully there's no one party that could really, really impact the blockchain in their favor. The cryptocurrency in their favor, sorry. But and again, I guess talking about being more concrete with things is that I'll now start calling a person on the network a node. So a node is just a computer on the network that downloads the software to generate their keys and kind of keeps the ledger up to date for them. So the idea is that in these cryptocurrencies is that these nodes, computers, are just always communicating 24/7, informing each other of the most recent transactions and making new payments stuff. So we'll call them nodes. That's what you would call them in the cryptocurrency world. So I think hopefully this would get really popular and take off. I would have lots of nodes on this network. And again, they're all communicating constantly. But even with this gossip protocol that we talked about, it's still kind of like, who do you listen to? Like, how do you even keep track of all this information? There's so much going on. You think about in finance, there's so many payments going on all the time that it would be really confusing. And there's some real problems that could happen if you don't have the most up-to-date information. So, like, although you can't forge an individual transaction, like you can't make someone else like pay you money, you can omit transactions. So like if I was evil, if you imagine I'm gossiping, I could make my computer not pass on certain transactions. So like if I had spent £10, I could choose just not to tell anyone. Or if I really didn't like someone else, I could choose not to tell other people that they had gained money. And there's kind of no way within the system to tell if there's transactions missing from our ledger. Like there's no sort of ordering to it. And ledgers would get out of sync. And it maybe seems like, oh, that's okay if you've not got a few transactions. But if you don't know that I at one point got £100, then I try and spend that £100, you wouldn't let me because you don't know that I have the money to do it. So you could have some very bad situations. Just going to take a quick question. So Rachel's asking, is everybody a node? And if you aren't one, automatically people will volunteer their computers to do this for no reward. Seems like a big ask. And what happens if they decide to turn off? So why would I be a node? So like a node is just a computer on the network that has a private key and has a public key and can pay people in Bitcoin, or yeah, Bitcoin at this point we're going to call it. So it's kind of free to be a node. Like it's, I guess you have to run your computer and you have to receive the most up-to-date ledger and stuff. But what you get from that is that you get to be part of this whole new currency, and you get to receive money from this, and I guess there's a ton of benefits to this whole currency. I mean, you've probably heard before about people like to use cryptocurrencies because they can send money over international borders, like tax-free. It's also anonymous as well because you're just using private and public keys. So there's a few reasons that you'd be a node, and it's not too expensive to just every so often just go on the internet and download the most recent ledger. So yeah, so hopefully that's relatively clear, but I can see why it's kind of confusing. So we have the system now where we're all communicating transactions. It's getting very messy because there's lots of transactions flying around everywhere. But I think what we need to do is we can't just update our ledger straight away when you get a new transaction. We need kind of everybody in the network to agree on what the ledger looks like at the same time. At any given moment of time, we all have to agree. Because if we don't agree, then some people would think, Fraser's really rich over here, but then other people would say Fraser's really poor, and everyone would disagree, and it would just get even more and more confusing. But we also need to make sure that if we have a definitive list of the next transactions to be added to the ledger rather, sorry, it's not, you can't just have one person that decides which transactions are put on the ledger. Because if one person decides which transactions are put on the ledger, then they're going to put their own transactions, or they're not going to put in the transactions of their enemies because they don't like them. They don't want their transactions to go through. And so everybody's transactions have a chance at being included in the ledger as soon as possible. So the way to fix this is our final ingredient, and this is kind of this is the name of the workshop. It's blockchain. This will hopefully fix our problems. And so what we do is we organize transactions into blocks. They're of a fixed size, so I think for Bitcoin it's something like 4 megabytes worth of transactions. And the idea is that everybody on the network will agree on what the next block should be, and then everybody updates their ledger at the same time. And then again, this way that there's nobody who disagrees about what the ledger is at any point in time. So one of the immediate sort of side effects of this is that because there's only so many transactions get into a block, it means that if your transaction is not on the block, then you've kind of got to wait around. So if you're waiting on your like 100 Bitcoin paycheck, if it's not on the next block, you're just going to have to wait if you want to spend. And that's why this guy here is kind of crying. So sorry. So before we go into that, so we have blocks. Okay, right. Okay, cool. We'll have blocks. But then again, how do we decide who makes the next block? Who decides what goes into the ledger next? And this is where we introduce miners or block creators. And so these are the guys that decide that fairly. We'll see how it's fair soon. So these guys, they listen for any new transactions on the network. See, they're getting communicated to the network by this gossip protocol. And they collect a list of valid transactions into a block. And not all block creators will choose to put the same transactions into a block. You know, they might pick ones that they would prefer, or they might just pick whatever one they'd heard first. So they collect this into a block, and they're hoping that this will be the next block in the blockchain. And then, so the way that they create a block kind of relies on this cryptography that we talked about before. So this is the same terrible slide that I had before. But again, it's this idea that we can take some sort of string of letters, combine it with some numbers, and we get another number at the other side that's in binary. But this time the process is kind of reversed. So what the miner is trying to do is they're trying to combine their block with a number to get this final string. But they don't know which number they want to combine it with. So the rule is in Bitcoin. This all seems very silly just now, but it all makes sense, hopefully. And so the goal is that the miners want to combine the block with a number that will give them a binary string with just 60 zeros at the start. So that's kind of an arbitrary kind of number, like 60 zeros. Like, why is that? But it gives them a goal. It gives the miners a set goal. And it would take a long time to do this because, as we kind of mentioned, it's really complicated mathematics that kind of that it takes to. It's very complicated and very chaotic mathematics. So you don't know when you combine a block with a number what the output string will look like. So you really just have to keep trying millions and millions of random numbers until you get the 60 zeros. And this is why mining is so difficult, because it takes a really long time. But there's a reason that we want it to be difficult, and I'll kind of explain that later. So it's difficult stuff. I'm going to check the chat. We're all good. So once a miner has found one of these numbers, they've done the work, they've kind of mined the gold, I guess you could say. Then that's it. They've made the next block. And they show everyone, here's my solution. You know, here's the number that you could combine with this block to get the desired number of zeros. And as a reward for this, then the miner also adds on a little bit to the end of the block, saying that they get a set amount of money. And so everybody agrees on what this reward should be. Everybody in the protocol agrees that when miners find a block, they get, say, 1 Bitcoin. But it depends on the blockchain. And so, okay, so cool. So we've been able to create a block, and this is called proof of work. The name's kind of, because it takes so much work to create a block. But the point is that even with thousands of miners in Bitcoin, it takes about 10 minutes to create a block. So it really is difficult guessing all these numbers. And like you might think like, oh, what is even the point of all this? But it creates a challenge and it creates a competition between miners to create the next block. And because of this, because there's this constant competition, it's unlikely that a single person will just keep creating lots of blocks and control the blockchain. So like, if you imagine it was really easy to make a block, then whoever wanted to could just make a block all the time. And you have blocks being created left, right, and center. And evil people could really do it. But with the fact that it takes so long to make a block, it's difficult to do that. It's kind of like, if you're that one guy who's evil, you're kind of fighting against the entire network to create a block. So it's unlikely that you're going to be the one that actually makes it. So it means that the blocks that are made are kind of not biased towards any one party. I mean, individual blocks might be biased to whoever made it, but because they're made by different people every time, the network as a whole is not really that biased. But then of course you start thinking, well, maybe actually if people did pull together their mining power, they could actually start to have some control over what's added to the ledger. So if you had lots of miners all working together to create blocks, to create evil blocks that are biased towards them, then they could actually start to have a bit of an impact on the ledger and the fairness of the ledger. And this would kind of all culminate in what's called a 51% attack, which is where one group has like half of the computing power of the entire network. So they can mine so many blocks. They can mine so many blocks that could literally create their own blockchain and control every single block on the blockchain. At which point the entire blockchain would probably crumble and the cryptocurrency would lose its value. And nobody would want to buy it anymore because it's controlled by one biased faction who could completely exclude all their competitors and stuff. So that's a bad situation. I should say that proof of work isn't the only way of doing this. It's not the only way of creating blocks. There's something called proof of stake, which kind of means like it's like if you have lots of transactions that you want to get through, then it gives you a little bit more of an edge and lets you create a block to kind of stop this from happening. But that's covered elsewhere. But it's not the only way. So there is ways of getting around these 51% attacks. But interestingly, if you look at Bitcoin, it really kind of is heading in that direction where there's Bitcoin.com has 20% of the mining power. So, and it tends to be these companies or these groups kind of monopolize the market as well. So as they get more and more power, they will control more of the blockchain. And again, you can imagine a situation where if one group controls all of the blockchain, then they could completely choose not to introduce anyone else's transactions to the blockchain. They could basically own this blockchain to themselves, kind of make it their own currency, because they just have so much computational power. And so Rachel asked, is a 51% attack possible? It seems quite improbable. And yeah, it does seem quite improbable. Like you would need a lot of computing power. I think it'd probably take quite a long time for one of these groups to get up to 51%. But it's definitely a possibility. And there's also theories that like more powerful computers, like quantum computers, could kind of throw this whole thing into doubt. Like if there was quantum computers, they could mine blocks like 10 times faster than our current computers. So whoever owns them could really start pumping out the blocks. So yeah, so it's possible. It's possible, and it's definitely something that has made people shy away from cryptocurrencies like this. Hopefully it's relatively clear how this new system works now. And to go back to our old standards of comparison for money, I can kind of compare this a bit here and see how does this actually, like, what was the point of this? Like, how is it better than what we've gone through before? So as a medium of exchange, it's pretty good. I would say, like, you only really need internet. You just need to communicate through internet. So whoever you're buying stuff from, if you want to pay in Bitcoin, you just send it over the internet. it kind of falls down a little bit in terms of like face-to-face transactions. Like there's not many shops that take Bitcoin, right? But there's now apps that you can get on your phone to buy and sell Bitcoin. And you can get credit cards as well that like store your money in Bitcoin and then transact it into pounds when you actually make the payment. So I think one of the big problems with cryptocurrencies is making it accessible for wider audiences. As a unit of account, it's pretty good. It's kind of just as good as digital paper money. You can send fractional amounts of Bitcoin. You can send really big amounts. And as a store of value, it has different issues to fiat money in terms of there's no trusted parties and there's no natural deterioration. So there's no one big bank that kind of controls all of cryptocurrencies and could take them down in one fell swoop. There's no kind of way for the poor management to affect it. I guess really this only thing that could happen like that is what we mentioned with a 51% attack. But there's cryptocurrencies that can get around that. And so there really isn't that much. There's no one person that has that much control. But the problem is that, and I can show you this with the chart, is that it's right now cryptocurrencies are not a good store of value. They are extremely volatile. So in green is the price of Bitcoin in dollars over the years. And you can see it starts off at $0 when the currency was first made and no one was using it. In 2018, it reached about $20,000. And now it sits around $12,000 or £8,000. But a lot of people would say that like the reason that it's so volatile is just because a lot of people don't use it. Like there's no big companies that really care that much about it and invest in it yet. So a lot of people who invest in it is more short-term investments where they'll like buy some Bitcoin and sell it all off trying to make money. So it's kind of like a chicken and egg scenario, I think a lot of people would say, where it's like if people use Bitcoin, the value would stabilize. But because nobody uses it, the value is erratic. So then nobody wants to use it because the value is so volatile. So the idea is that when the price does stabilize, it will be more like a real currency. And there's been something that's come about more recently, which is called Tether coins. I can't think of the name of it, but the value is, I think it's called Tether actually, sorry, where the value is kind of tied to the US dollar. So it's like a cryptocurrency, but its value kind of follows the US dollar. And I won't explain how that works, but it's obviously more stable than just like your standard cryptocurrency that has no intrinsic value. So it is possible to back cryptocurrencies with other currencies to kind of give them more of their own value. So that's the crazy price of Bitcoin. And it is big money. There's lots of new cryptocurrencies that have sprung up trying to kind of find success. There's Bitcoin, and the second biggest one is Ethereum, which I'll talk about later. That's got some interesting things in it. Then there's Ripple. There's Bitcoin Cash, which was created as like a fork from Bitcoin. So basically, it's kind of interesting. Like about half the people, I think, with Bitcoin Cash, what I remember reading is that they disagreed on how many transactions you should put in a block. So kind of overnight, half of the people on the Bitcoin network started using 200 transactions in a block, and then the other half started using like 400 transactions in a block, and the blockchain just split. And it split into two different currencies. It's called Bitcoin Cash and Bitcoin. And so that's kind of the interesting thing, is that these blockchains could actually split up into little smaller currencies. But the nice thing about it is that there's no one that says, this is the way the cryptocurrencies have to be. Like if you have enough friends, you can start your own cryptocurrency. You could fork off from Bitcoin and start doing your own thing. Like nobody has to accept your transactions and update their ledger from what you've given them, because what you've given them isn't compatible with their protocol. But you can do it if you like. Like if I wanted to, I could go and make a cryptocurrency tonight, probably. But no one would have to use it. So I mentioned Ethereum. This is kind of the last sort of thing that one of the most recent developments with it is that people have realized that there's kind of a lot more to this than just money. Like you don't have to stop there. you can record really any relation between different nodes on the blockchain. So like you could use it for legal contracts. You could use it just to store files, to store information, or you could even use it for video games. Like there was this one example, it was ridiculous. It was called Cryptocurrencies, and it was basically like instead of transacting like money, like Bitcoin, you transacted cats, like digital cats. But then also because it's stored on a blockchain, it's like there's no way for someone to steal your Cryptocurrencies, and you could trade Cryptocurrencies over this blockchain. And it actually turned out to be a really popular app. And all of this is kind of the idea of smart contracts, which was popularized by this Ethereum platform, which I mentioned is has the second biggest market cap of all the cryptocurrencies. And so it's a lot more general than Bitcoin. I'll just double check the chat. We're all good. A different time. Okay, perfect. So that's kind of my little introduction to cryptocurrencies and blockchain. I hope now you're a little bit more clued up on what the hell blockchain even is, and maybe now you want to learn more about it or even use it. As I mentioned, like you can download apps on your phone if you want to start trading cryptocurrencies. Just remember, it is extremely volatile, but at least now you kind of maybe know why it's so volatile and why it's such a risky investment opportunity sometimes. And I think one of the important things about blockchain is that even if it doesn't turn out to be right, and it doesn't turn out to be, it doesn't impact the world the way that we think it will, it turns out like the ideas behind it have really kind of changed the way that people think about finance and the trust that you place in a lot of financial institutions. And I think maybe our grandchildren won't be trading with cryptocurrencies, but maybe something like that. So yeah, thank you for listening. So weird just hearing the silence of a YouTube live stream. I'm not sure if the slides will be released, but I've left some resources here. There's something called the Bitcoin white paper, which is what the creator of Bitcoin released when he first was trying to popularize this currency and get people to use it. And it's like a step-by-step explanation of how everything in the Bitcoin network works. There's a lot more to it, like that I haven't covered here, a lot more technical stuff. But I would say read the white paper, it's really interesting. And of course, Bitcoin.org and Ethereum.org. To be fair, there's actually a whole bunch of other things that I can link you to. I'll drop some of the things in the chat right now. Yeah, thank you for listening. So I was trying to find a good cryptography video, but actually while I'm here, I might just put this on to show you how. Oh, sorry, I can't actually leave comments. My tech skills are really showing here. Is the white paper not a Satoshi thing? Yeah, fun fact about the Bitcoin white paper is that it was created by someone who nobody knows their real name. I think they just went by the name Satoshi Nakamoto. And we have no idea who the creator of Bitcoin is, but he wrote this paper and it disappeared. And thank you for the compliment. Thank you. I don't know what the future comes. They really told me what to do in the last 5 minutes. So a little bit more about the FinTech Society. We've got AI workshop on this month. Follow us on Facebook. We've also got Discord. We've also got a WeChat group. We've also got a website. Check us out, Edinburgh Uni Financial Technology Society. We've got lots more events on. We're going to be covering AI. We're going to be covering data science. We're going to be covering open banking. the applications of like fintech and banking. So lots of things. Check us out. And I think I'm cool to end this now. But yeah, I hope you enjoyed, and have fun at the Future Conference.